pun tak boleh tanah ni Aduh, pusing lah.
Buat apa?
Ni ada tanah tinggalan Datuk Uri. Tak tahu lah mana nak cerita.
Itu nak buat apa?
Kalau tak tolong kira kan. Dia itulah dia macam mana nak settle tutorial harga dia. Situ lah perlu dia dapat tangan kan. Satu hari pula.
Tengok jap. Sorry dong.
Susah.
Susah je.
Macam mana tak ada orang lain yang lagi okey. Yang lagi kira kita yang nanti kan.
Pakcik boleh tolong.
Wait, mana dia datang?
Tahu. Siapa pakcik?
Pakcik dah lama kat sini ni. Kamu tak perasan pakcik dari sini duduk sini memandang kamu?
Ya ke?
Kami tak perasan pun.
Pakcik ada lah pakcik ni. Pakcik ni ada ilmu serius sikit.
Kejap. Aku rasa aku kenal pakcik ni.
Siapa?
Pakcik Imran kan?
Flashback.
Bukan Imran. Itu anak saya. Pakcik ni pakcik ayah kepada Imran. Kamu ni dah kenapa?
Bukan dia dah mati ke?
Apa jadi? Pakcik? Oh lah. Macam mana boleh pakcik habis ni?
Dah lah ni. Sekarang ni kamu ni nak pakcik tolong kan? Pakcik kamu ada masalah kan?
Adalah masalah pribadi.
Lah, tapi banyak.
Biar pakcik tolong.
Allah Akbar.
Kenapa terkejut-kejut ni?
Tak pakcik tinggal tak ada situ ni.
Pakcik jadi kuat ke?
Dah tak fikir lah okey. Ni. Allah, biar pakcik tengok.
Betul ke pakcik ni?
Ini senang je ni.
Macam mana?
Biar pakcik tolong. Kamu duduk tengok betul ni. Macam ni.
Assalamualaikum and hello everyone. So today we were assigned to make a video about application of differentiation. Before I dig into the topic, let me introduce my team member. First, we have Muhammad Adli Fadlan bin Azami. Next, we also have Putra Nakiuddin bin Muhammad Sofian. And lastly, Rika Izara binti Ramli. So, what is differentiation? Differentiation can be defined as a derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. There are a few applications of differentiation. There are related rates, analysis of function 1, analysis of function 2, apply maximum and minimum problem, and lastly, Rolle's theorem and mean value theorem. Then, what is apply maximum and minimum? Apply maximum and minimum is the process of finding maximum or minimum values is called optimization. Besides that, why we apply maximum and minimum? For example, we apply maximum and minimum to maximize the profit in a company, or minimize the cost, or find the least amount of material to make a particular object. Next, let's move on to the procedure. Here are the steps that we need to follow. First, find the derivative. Second, let the derivative equal to 0 and find the value of the variable. And lastly, do the second derivative test. If second derivative larger than 0, means it is minimum value. But if second derivative less than 0, means it is maximum value.
So now moving to problem statement. Given the area of a rectangular garden is 1000 meters square, Adli, who is the owner, wishes to enclose the garden on one side by a brick wall costing 30 ringgit per meter, and on the other three sides by a metal fence costing 10 ringgit per meter. So the first question is, show that the cost of the material is C equal to 40x plus 20,000 over x. Second, find the dimension that will minimize the cost, and third, hence finds the minimum cost. Ha, that's so easy. Let me show you how to solve this in problem solution. So the first question is, show that the cost of material is C equal to 40x plus 20,000 over x. So first, by looking at the picture, we can see that cost C is equal to 40x plus 20y. We can gain this by adding all the parameters. So now to prove this statement, we need to get y. To get y, we need to use the area of the rectangular, which is xy equal to 10,000 meters square. Thus, we will get y equal to 10,000 over x. After this, we use this statement to replace y inside C. So 40x plus 20y, replace y with 10,000 over x, and we will gain 40x plus 20,000 over x. Next, find the dimensions that will minimize the cost. Step 1. Find the derivative. To find the derivative of C, we will need to differentiate C. So after we differentiate C, which is 40x plus 20,000 x power of negative 1, we will gain the derivative 40 minus 20,000 x power of negative 2, or 40 minus 20,000 over x power of 2. Second step, let the derivative equal to 0. By doing this, we can gain the amount of x. So 40 minus 20,000 over x power of 2 equal to 0. We then get 40 x power of 2 equal to 20,000, and by dividing, and after we divide 20,000 with 40, we will gain x power of 2 equal to 500, and after we square root the x, we will get x equal to 20.36 meter. Next step, second derivative test. So by using the first derivative, we will differentiate them, and it will turn into 40,000 over x power of 3. It proves that x is a minimum value. So when x is equal to 22.36 meter, y will be 44.72 meter. Lastly, find the minimum cost. To find the minimum cost, we will need to use the formula 40x plus 20,000 over x, and we will replace x with 22.36, which we just gained, and we will get 1,788.85 ringgit.
Oh wow, now I know how to solve my problem. Moving on to the conclusion. Therefore, identifying the correct derivative will lead to the values of the variables. The test for the second derivative is important to determine the value, either to find the maximum values or minimum values.
Oh, macam tu.
Senang je buat simple.
Itulah kita tadi buat susah nak fikir rasa.
Lama lagi.
Betul?
Rasa ni kau pakcik ni.
Itulah. Rasa banyak pakcik
Weh, mana pakcik tadi?
Budak-budak aduh, macam orang main-main lah pakcik.
Tapi tak apa. Kita settlekan ni.
Betul?
2 hours later.
Nasib
Masalah.
Banyaklah. Apa kerja kat sini? Masalah kau bukan masalah aku.
Oh. Tapi tu dah tak aku.
You. Gerak.
Bye. Lelo je.
Okay.
Weh, kau dah kenapa?